Today we're gonna start with your physics class, that is your class 38 here, where we have completed your 37th class of the session. So in 38 class we will start discussing about unit 5, which is the laws of motion. We have done unit 4 as well. So in unit 5 we have done related to the numericals of the motions of particles of mass, and as well as many things in the detail. So stay tuned with us and please go for the playlist. You will find out the video as well. In unit 5, the laws of motion, which we discussed here, is your start discussing about the impulse here. So you're ready for it. So today we'll start discussing about impulse. But before starting with this same, it's a huge request to please go ahead with like, share. So discussing about impulse. In same way for the impulse here, that we sometimes encounters an example where a large force acts for a very short duration, producing a finite change in momentum of the body. For example, when a ball hits a wall and a bounce back, the force on the ball or the wall acts for a very short time. When the two are in contact, yet the force is large enough to reverse the momentum of the ball. Where often in these situations the force and the time durations are difficult to ascertain separately, and however the product of the force and time, which in the change in the momentum of the body, remains a measurable quantity, and this product is called impulse. Yeah. So impulse का formula क्या है? Basically you have to know about that. Impulse equals to force into time duration, which is equals to changing momentum. So here for that, a large force acting for a short time to produce a finite change in momentum is called impulse force. In the history of science here, so for that that in the history of science, that impulsive force were put in a conceptually different category from the ordinary forces, where the duty here that Newtonian mechanics has no such distinctions. Impulsive force is like any other force, except that it is large and act as a for a short time. Okay, so now we go for a numerical here, which is of course very important one. But before starting with the numerical, it's a huge request to all the viewers. Okay, go ahead with the numerical by your side, so that it will let you know that are you able to or are you capable of doing or solving those questions. So that is very important for the self-analysis. Let's go for the question here. The question here, and then for this particular unit we have your question is your fourth question, and we had done your 3 questions in the last classes. So the question we have, which is a batsman hit back a ball straight in the direction of the bowler without changing its initial speed of 12 meter second inwards. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. Assume linear motion of the ball here. So that we gonna discuss about it, which is in the detail. We'll discuss. We'll find out the changing momentum here. So here we go. A batsman hits back a ball straight in the direction of the bowler without changing its initial speed. Of 12 meter second inverse. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. Assume linear motion of the ball. Okay, I will go for it and we'll find out the solution for the same. So here we go. So we'll find out the change in momentum here. Okay. Change in momentum, which is 0.15 into the batsman hits a ball straight in the direction of the bowler without changing its initial speed. Impulse को follow होता है force into time, that is time duration, which is change in momentum. So its initial speed 12 meter per second, of course, that is 12 minus 0.15 into 12. Okay, let's go for the solution here. We'll solve it out. Multiply 3.6 meters per second. So impulse Newton is the unit of force, and the time unit is your second. It is Newton second here. So impulse is your 3.6 Newton second in the direction from the batsman to the bowler. So this is an example where the force or the ball by the batsman at the time of the contact of the ball and the bat are difficult to know, but the impulse is readily calculated. I will discuss about your, that is Newton's third law of motion. So here we go. Newton's first law we had discussed. Newton's second law as well we had discussed. I will discuss about the Newton's third law of motion, which has of course been important here. Newton's third law of motion. Newton's third law of motion. The second law relate the external force on a body and its to its acceleration. What is the origin of the external force of the body? What agency provides the external force? The simply answer is the Newtonian mechanics, in that the external force on a body always arises due to some other body. You have to consider a pair of body like A and B. B gives rise to an external force on A, and a natural question is, Does A, it return gives rise to the external force, or B? In some examples, the answer seems clear. If you press a coiled spring and the spring is compressed by the force of your hand, the compressed spring in turn exerts a force on your hand and you can feel it. But what if the bodies are not in contact? The earth pulls the stone downward due to gravity. Does the stone exert a force on the earth here? That is the question arise. The answer is not obvious since we hardly see the effect of the stone on the earth. The answer, according to the Newton, is yes, the stone does exert an equal and opposite forces on the earth, and we do not notice it since the earth is in a very massively, and the effect of the small force on its motion is negligible. Thus, according to the Newtonian mechanics, force never occurs singly in nature. Force is the mutual interaction between two bodies, and we are, you know, in terms of forces that always occurs in pairs. Further, the mutual forces between two bodies are always equal and opposite here. The idea was expressed by Newton in the form of the third law of motion. To every action, there is always an equal and opposite reaction. That is the third law. You have to write it down. Newton's third law of motion. To every action, there is always an equal and opposite reaction. For here, the Newton's wording of the third law is so creep. So in the same way that it becomes for a part of a common language, and for the same perhaps it is conceptions here, that is your the interconceptions that we'll discuss, that misconceptions about the third law of about, and let us wrote some points about the third law, particularly the regard to the usage of terms actions and reaction. So we go for it. So in terms of it, the first will the term action that we'll discuss here, which is of course be the important one. So the term action and reaction in the third law mean nothing else but force. Using different terms for the same physical concept that can, sometimes be confusing. A simple and a clear way of stating this third law is as follows. You can see that we have another point. So that is the forces always occurs in pure force on a body A by B is equal and opposite to the force on the body B by A. Okay, so here that is the forces always occurs in pairs, and that forces on the body A by B is equal and opposite to the force on the body B by A. So the another term that we'll discuss here in the detail is your the terms actions and reaction in the third law may give a wrong impression that action comes before reaction. That is, the action is the cause of the reaction of the effect. So there is no cause effect. We'll just write it out. So there is no cause effect relation applied to the third law. The force on A by B and B by A act at the same instant. Okay. Now here by the same reasoning, by the same reasoning, any one of them may be called action and the other reaction. The third, we have a point that to be discussed here, which is action and reaction forces act on different bodies, not the same body. Consider a pair of bodies A and B according to the third law will be having as that is the another point, so we'll discuss with different one. Which is FAB is equals to minus FBA. Okay. So the same way, force on A by B equals to the force on B by A here, which is force on A by B equals to minus force on B by A. Okay. Now here, thus, if we are considering the motion of any one body, A or B, only one of the two forces is relevant, and it is an error to add up the two forces, and they claim them that it force is zero. And however, if you are considering the system of the two bodies as a whole, FAB and FBA, that are the internal forces of the system A plus B. They add up to give internal forces. Internal forces in the body are a system of particles. That is a system of particles, thus cancels away in pair, and this is an important fact that enables the second law of applicable to the body or the system of particle here, that we'll discuss of course in the next coming classes as well, in the next coming chapters as well. So we'll discuss the numerical here, which has been of course important one, so that it will be completing the Newton third law of motion after a while. So starting with the question we have: two identical billiard ball strike a rigid wall with the same speed but at a different angle and get reflected without any change in the speed. That I will show you how what are they are saying. You have to find out what is the direction of the force over the wall due to each ball, and that the second thing you have to find out the ratio of the magnitude of the impulse imparted to the balls by the wall. So let's get started here. So we have here question number 5. Two identical billiard ball strike a rigid wall with the same speed. but at different angle, and get reflected without any change. In speed. What is the direction of force on the wall due to each ball? So first thing what we have to find out, the direction of the force on the wall on the wall due to each ball. The second thing we have to discuss, the ratio of the magnitudes of impulse imparted to the balls by the wall. So we have a diagram here. X, Y. This is for A and for B. This is for you. And they are making a marginal angle 30 degree each, and so it is total is 60 degree. This is the B diagram. Okay, we're gonna solve it. So for this, here instructions that answer to the first, that might that the force of the wall in case, and for the A is that is double to the wall, and while that in the case of B is inclined at 30 degree to the normal, and this is the this angle also is wrong, and that the force on the wall is normal to the wall in the both cases. How to find the forces of the ball? That the trick is to be consider the force or impulse of the ball due to the wall using the second law, and then use the third law to answer. Let u be the speed of in each ball before and after collision with a wall, and m be the mass of in each ball. choose the x and y axis as that is shown in the figure and consider the change of the momentum of the ball. So for case 1, that is your case A, px initial u and px final is minus mu. Say for py initial equals to 0 and py final equals to 0. So impulse in the change in momentum vector, therefore x component of impulse is -2 and y component of impulse is 0. So we go for it. So for that we have x component of impulse equals to -2 mu and y component of impulse equals to 0. So here impulse and forces are the same in direction and carry for above. The forces of the ball due to the ball is normal to the ball along the negative x direction, and using the Newton's third law of motion, the force on the ball due to the ball is normal to the ball along with the positive x direction. And the magnitude of force that cannot be asserted since the small time taken for the collision has not been specified in the problem. So we'll discuss the case 2. That is your case B. Px initial equals to mu cos 30 degree, and for py initial that is your m minus mu sin 30 degree. For px in final equals to minus mu cos 30 degree, and for py final equals to minus mu sin 30 degree. Now while px that changes the sign after the collision, py does not. Therefore x component of impulse equals to -2 mu cos 30 degree, and y component of impulse equals to 0, where the direction of impulse and the forces is the same as in A and is normal to the ball along with the negative x direction as before using the Newton's third law. The force of the ball due to the ball is normal to the ball and along with the positive x direction imparted to the ball in A and B. So for that we will be discussing here, which is your 2mu slash 2mu cos 30 degree equals to 2 by under root 3, which is 1.2. That is we get as an answer. So now we'll discuss in the next coming class. Stay tuned with us and please keep supporting us as you have supported till the date. Thank you. Please like, share and subscribe so that the maximum people can get the information to us, and everything you can also enjoy the video as well. Thank you.